What does the Web 1.0 mean for science?
So scientists have always used computers to help them solve their problems since the very beginning. In fact, the first computer in Cambridge was used to do X-ray crystallography calculations. The web has made a lot of data available for scientists. Indeed, the first web browser and the concept of web browsing was invented by CERN, the physics lab in Europe. With the web, scientists have been able to share their data with each other, to collaborate together, to communicate their papers and to store those online. And so it's very much speeded up the pace of scientific discovery and innovation and sharing.
How does Web 2.0 impact science?
So Web 2.0 kind of takes it on to the next stage. The social technologies that define Web 2.0, things like wikis and blogging, are much more a two-way medium. And indeed that was part of Tim Berners-Lee's initial vision for how the web was going to evolve. And so it makes it possible for people to collaborate together on experiments, to collect their knowledge together and to find ways of building scientific reputation, of comparing experiments, of labelling their data more semantically so that it can be used by other people's tools and explored. So it makes it a much more closely coupled world, a much richer world. It brings a lot of problems with it. What's the provenance of data that's on the web? What were the external circumstances at the time I ran my experiment? What was the weather? Was there sunspot activity? Because those might be scientifically significant things. And indeed, how do we archive and preserve that data? How might I go back to previous versions of the data or previous experiments if I find that one set of data is wrong? So it's connecting scientists in a much more active way, enabling them to collaborate much more actively, but brings a whole batch of new issues with it as well.
What do you see as the future for scientific computing?
So I think computing is really changing the sciences. We're moving on from the idea of the computer just as a fast calculator for the scientist. People are making use of data mining techniques to go over the large amounts of data that have been collected and make new discoveries by correlating things that previously haven't been compared. We have real challenges in organising the amount of data, particularly that being produced in physics experiments such as the Large Hadron Collider, and that's making people look at distributed computing and indexing techniques and so forth. Interestingly, in other areas, ideas for computing are being used to fundamentally define the way science is being done. Colleagues in my research lab here in Cambridge, for example, are taking ideas from software specification and verification, where they use mathematics to model software and prove the correctness of software algorithms. They're using those ideas to model biological systems. They're quite similar in a way. They consist of objects called cells that send chemical messages to each other. And what we'd like to do is understand the properties of how those systems work. And we've made some progress. We've already got a model of some parts of one of the major immune pathways in the human body. And I think the impact that will have on the biological sciences and on healthcare and so forth will be very significant. So we're kind of seeing the emergence of new computational sciences, and that's very much in addition to accelerating the pace of development in the major sciences that have always been with us.